So, good afternoon, all the participants. We are having a second session of the day, and with us, we are having our expert, Dr. Dheeraj Kumar Singh. So, before he starts with the session, let me give a brief introduction about him. Dr. Dheeraj Kumar Singh obtained his PhD degree in physics from Banaras Hindu University, Varanasi, India in 2010. After getting his PhD degree, he joined CSIR Nehru postdoc at NCL Pune for 1.5 years. Further, he moved to Seoul, South Korea as a postdoc scientist and worked there for 3 years. After completed his task in South Korea, Dr. Singh was awarded with prestigious international award as Alexander von Humboldt Fellowship and worked for 2 years at Jacobs University and University of Bremen, Germany. Dr. Singh was also awarded with prestigious international award as JSPS Fellowship Japan in 2016. A part of this, Dr. Singh was also awarded with various national fellowships and awards like Dr. D.S. Kothari Postdoc Fellowship UGC, Research Fellowship in the Science for Meritorious Students UGC RF SMS, CSIR Nehru PDF, and CSIR SRF, etc. Currently, Dr. Singh is working as an assistant professor of physics at Institute of Infrastructure Technology, Research and Management, Ahmedabad, an autonomous university, Government of Gujarat. IITRAM was earlier recruited and monitored by IIT Gandhinagar itself. Dr. Singh has been awarded with ECR project amount of rupees 50 lakhs by SERB DST Government of India and DST Inspire grant for his PhD student. Right now, one PhD student has received PhD degree under his guidance and four are currently working. His research is mainly focused on frequency and time domain spectroscopy based on IR, Raman, UV visible and fluorescence, along with functionalized nanomaterials, quantum chemical calculations, ab initio and DFT, ionic liquids, biomolecules, molecular interactions. He has published more than 60 international journal papers, 6 books chapters, and 1 international patent published and granted by the USA. Dr. Singh is actively involved as a reviewer in journals like JPC, ABC, Journal of Molecular Liquid, Vibrational Spectroscopy, Chemical Physics Lecture, etc. He is the life member of LASSI, MRSI, EMSI, ICAMP, KCS, etc. He has organized 3 conferences and the workshops at IITRAM. He has published 2 books as a lead editor on advances in spectroscopy, molecules to materials in Springer Nature publications. I heartily welcome you, sir, in this session as an expert. And hopefully, this session will be very beneficial to all our participants. So, over to you, sir, for the session.
Thank you, Professor Sanju, for the nice introduction. And first of all, I would like to thank the organizers, especially Professor Sanju, for inviting me in this prestigious 5 days ATAL FDP program at Rajasthan Technical University, Kota. I hope everyone will be beneficial from my lectures on basics of nanomaterial. So my screen is visible here?
Yes, sir.
Okay. So today I am going to present about advancement of nanomaterials, fundamentals, synthesis, and application. Basically, I will be focused on 4 types of nanomaterial. First, very simple nanomaterial synthesis of metal nanoparticles, especially metal gold nanoparticles, silver nanoparticles, or platinum nanoparticles. How we can synthesis in our simple laboratory and how we can apply these types of nanomaterial in scientific and technological application. Further, I will show some recent research published from my research group on the field of gold nanoparticles and silver nanoparticles. Further, we will start our lecture on metal oxide nanoparticles like silver oxide or titanium oxide, zinc oxide. What is the synthetic route about the metal oxide nanoparticle? How we can apply this metal oxide nanoparticle in various research fields like solar energy harvesting or nanoelectronics, where it can be very, very useful. Further, I will come on carbon-based nanomaterial like graphene, fullerene, and other carbon-based nanomaterial synthetic route and their application, and how we can characterize all this nanomaterial using various techniques. In the last, I will also show the role of metal nanoparticles, especially in surface enhanced Raman scattering, and apply as a sensing property of some explosive material like RDX, TNT, and nuclear material sensing and some hazardous material sensing using the nanomaterial. Further, I will try to show the application of nanomaterials in various field of biomedical application like virus detection, how the nanomaterials can be helpful to detect the viruses, and also cancer cell are another particles using the nanoparticles application. So for this purpose, actually already Professor Sanju has defined my research journey from PhD, BHU to Nehru postdoc at NCL Pune CSIR in gold nano clusters and gold material for various applications. Further in South Korea, 3 year journey, and Humboldt postdoc at Germany for 2 to 3 years. Further JSPS fellow in Japan and some research journey at IITRAM. So for this purpose, actually I have divided my presentation in 8 distinct points. First, I will come on fundamentals of nanoscience and nanotechnology. Most probably, if there are some beginner who are going to start their research journey in nanoscience, they can be beneficial from this starting point of the nanoscience. How the milestones was there, what is the property changes if we are going from bulk material to nanomaterial. So how the shape, size will be changed and why it is important, nano dimension is important. So I will discuss it more detail. And how nanoscience can be defined by the quantum confinement effect. And further, I will discuss the synthetic route, all of nanomaterials synthetic route like top-down or bottom-up approach. What is the meaning? Further, I will describe metal oxide, and carbon-based nanomaterial, their novelty, and nanomaterials for sensing the various types of material, and nanomaterial for biological application. And I will show some possibilities to detect the coronavirus also using the nanomaterials application. And final, I will conclude our lecture. So, as you know that our periodic table has definite number of element in our, like 118 element is quite limited in number and it can be discovered. And but you can show that by combination of various element like carbon, hydrogen, oxygen, nitrogen, various combination of the element, now we are able to make a lot of material which can be exist either in liquid, solid or gas form, which can be very very beneficial for living world. Even many drugs molecules can be made by all this material. And what is the role of nanomaterial? Actually, idea will be started from here. You can see that mankind has been constantly trying to overcome its physical limitations of that particular material. Now, as for example, we can say that animal like horse can gallop at high speed and only the birds can fly. But by inventing the various appropriate material by various concentration or various mixing, now humans are able to develop vehicles that run faster than a horse and fly in the sky, reaching a height impossible for a bird. Example, any uh, aeroplane or any shutter plane or any other aeroplanes like that. So humans have developed the communication and navigation system which make them instrument to distinct planet. Like without approaching directly for human at particular space, we can send our some particular material through our spacecraft to understand the planet and the stars, environment design, and further galaxies information about there. So without reaching there, so means overall we need to make some material. Now this beauty of this material can be more important when we come in the nanoscience. So nanoscience generally is the manipulations of the material in nanoscale. So why it is important? Why surface to volume ratio increased and why only nano dimension is important? I will show you. So before coming to the basic definition of nano, so I would like to define the nanotechnology spans many research area. It is not only branch of any one branch of physics or chemistry. Even nanoscience exists in all branches of science and technology. Even physics, chemistry, biology, material science, engineering, electronics, mechanical engineering, everywhere nanotechnology as people are using. And due to this important, DST, Department of Science and Technology, also established a nano mission from the government of India. There is a one nano mission government scheme has been launched earlier before 10 days, 10 years ago about that particular thing. So milestone in nanotechnology. Actually, nanotechnology is not very new because the first gold nanoparticles were synthesized in 1857 by Michael Faraday. This is a milestone in nanotechnology, where still that particular nanometal which was synthesized in 1857, it is still available in the Museum of UK. That is a very famous Michael Faraday, beautiful color, Miranda color of gold nanoparticle are available. The idea was actually very old, but now research area were started after the first lecture, or you can say very famous lecture of Richard Feynman in given by 1959, who got the Nobel Prize about that lecture. But 1915, we can say Ostwald, a famous chemist, wrote a book, World of Neglected Dimension in German language. After 1930, Iriska and Knoll developed the first electron microscope, because nanomaterials dimension only can be characterized, the morphology, shape and size can be characterized by electron microscopy like STREM and TEM. So in 1931, first electron microscope was developed, which shows the very nice development in the area of nano. In 1951, E. Miller developed the field on ion microscope. After 1959, you can see 1959, Feynman delivered his now very famous talk. The talk was there is a plenty of the room at the bottom. Actually, it was a very famous lecture, got the Nobel Prize in 1959. This lecture, actually many scientists were motivated by this information, by this lecture. And after this lecture, actually research was started in this area of the nanoscience. That's why in 1968, A.Y. Cho and J. Arthur developed molecular beam epoxy technique for layer by layer growth of the material. In 1970, demonstrated the quantum size effect in semiconductor. After 1980, 1981, and 1985, a lot of development were there. Like such an example, in 1985, carbon-based nanomaterial got the Nobel Prize in area of fluorine, also in carbon nanotube or graphene. So after 1991, as Ishima discovered carbon nanotube. And now you can say carbon-based nanomaterial are very highly important. Such an example, now you can imagine what is the application of graphene, how you can synthesize graphene, and how you can apply graphene in various research fields. So we can assume any research area, you can assume where graphene have direct application in application as a scientific and technological application. Whatever in bacteria filtering, either in electronics, either in solar energy, either in hydrogen absorption for the vehicles, giving the mileage larger than petrol, means every area carbon-based nanomaterial like carbon nanotube graphene are very important application. So now application of nanoparticle more precisely it is given here, means you can see in healthcare, you can see the nanomaterial can be helpful for UV protection, antibacterial. In renewable energy, means that is renewable energy, that is basically in solar energy, wind energy, or thermal energy, or you can say geothermal energy, hydrogen energy. Actually, the nanoparticles are very important. Like nowadays in future, our vehicles are lithium ion battery. So what is the role of nanotechnology in lithium ion battery in order to enhance the efficiency of the solar energy? The hydrogen storage material like carbon-based nanomaterial are very important here. Fuel additive, fuel cell, catalysis, environment, you can say in CO2 capturing environment, what is the nanotechnology role? In electronics, it is have. So a lot of application of this nanotechnology is here. In cancer therapy, like gold nanoparticles have a lot of application. Similar way, whatever research area you can imagine, now nanotechnology have direct application. So few of them technological application I will cover in my lectures. So let us come what is a nanoscience. Nano is a nano is the dimension of 10 to the power minus 9 meter. Nano actually is a Greek word. Nano is a Greek word. Greek word means as a dwarf. Dwarf means small. So actually idea of nano is taken from that dwarf word as a Greek word. And nanoscience is the study of phenomena and manipulation of material at atomic, molecular, and macromolecular scale, where properties differ significantly those from larger scale. And if you know that almost all the material can be manipulated in nanoscience regime. Means if any material you have changed its size from bulk material to nanos, its properties will be significantly changed because of surface to volume ratio. I will give the example why the surface property will be changed. So means nano means that in manipulation of your materials or atomic level or molecular level in nanoscience. And you can see that the properties will be significantly changed and the same time size will be small. Means suppose if any material is conducting in bulk level, then it can be semiconductor in nanoscale level. So it means that same time you are going to decrease the size and you are going to tune the physical and electrical and optical properties of that particular material at nanoscale. And nanotechnology are design, characterizations, production, and application of structure, devices, and system by controlling shape and size of nanomaterial. Because you know that changing the shape and changing the size of your nanomaterial will be results into various kind of application. Like any material, like gold nanomaterial have 20 nanometer size, and if gold nanometal have 200 nanometer size, both have different application. Means you can tune the electronic, structural, optical, magnetical property of nanomaterial by changing the different shape and size, and for various desired application to what types of structure, what types of information you want. Different shape means you can design spherical shape, nano rod shape, nano triangle shape, nano case shape, nano flower shape, whatever shape you can design. Every shape have different application. That's why people are interested to design different shape and size of nanomaterial using various method. So nano scale is exist in every branch of the science and technology, in even biology, botany, zoology, every part of people are using in this part of it. So size of a nano is that 10 to the power 9. And you know that macro size is 10 minus 3 meter. Means you can say that that is bulk material is in terms of 10 to the power 3 meter. And micron size that is 10 minus 3 meter. But why nano? Nano is important. That is 10 minus 9 meter, because quantum realm will be there. Quantum confinement effect is very important. And why nanometer will be important, I will show you. So nanotechnology is small, different, but it is new. The nanometer is extremely small. At the nanometer scale, metals may behave very differently than compared to bulk material. I will show some example also. We can harness this new behavior to make new technologies. So such an example, some few ideas should be there. Okay, how much typically nanomaterials can be contained in a any atom? Means generally a nanometer or nano system can be contained 100 to 10,000 of atoms in one nanometer. Because you know that atom size, what is the atomic size of atom? Like carbon atom will be there. The atomic size, you know that generally 10 to the power minus 10 angstrom, I think. Now, suppose in nanometer is larger than angstrom. It means that how many number of atoms will collect together and make a nanoparticle. We call it nucleation. Means many atoms will collect together and nucleate together, and there are certain growth in particular direction, and we make a nanomaterial. It means suppose your material nanometal is 50 nanometer in size. So it means that in 50 nanometer size there should be more than 500 or 1000 atom will be involved to make the nanoparticles. So this is the importance of the understanding of the material, ki how much atoms or molecules are there in order to form the nanomaterial. Example of here carbon atom, you can see Bohr radius is 0.09 angstrom, and carbon atom van der Waals radius 0.17 nanometer. So in 1 nanometer line, 3 carbon atom can be lined up. And in 1 nanometer square surface, 9 carbon atom, and 1 nanometer cube, that is 20 carbon atoms can be aligned. And if you talk about 1 meter cube, then there would be more than 10,000 carbon atom can be aligned. So this is the giving idea that your nano size will contains a lot of atoms by construction. When I will discuss about the bottom up approach of synthesis of nanomaterial, then we can see that. So how big is a nanometer? You can see in our nail, in time it takes to read this sentence, your fingerprint will have grown approximately 1 nanometer. So that's why nanometer is very small. That's why you need to characterize this nanometer electron microscopy by TAME and SAME, scanning electron and transmission electron microscopy, which was discovered by 1974 after that. So this was the first lecture who got the Nobel Prize in 1965. This famous lecture was given by Richard P. Feynman in 1959, and the topic of that very famous lecture was plenty of the room at the bottom. What means the plenty of room at the bottom is that actually in that lecture, Feynman did not take the name of nano. He just giving the... Sorry? Hello, my voice is clear?
Yes, sir, your voice is clear.
Okay, thank you. So in this lecture, Feynman did not take the word nano, but he only gave a possibilities to manipulation of any material at a nano scale. After motivating this lecture, he requested to a lot of scientists to discuss and think about this direction to manipulate of the material in nanoscale regime. after starting this lecture, a lot of research is started to done in nanotechnology, and the famous research started from after 1965. So what was the topic is that he told that I would like to describe a field in which little has been done, but in which an enormous amount can be done in principle. This field is not quite the same as the others in that it will not tell us so much fundamental physics. What are the strange particles? But it is more like solid state physics in the sense that it might tell us much of great interest about the strange phenomena that occur in complex situations. Furthermore, a point that is most important is that it would have an enormous number of technical applications. What I want to talk about is a program of manipulating and controlling things on a small scale. So this was the main motivating line from his lecture, manipulating and controlling things on a small region. So after this lecture, actually 1974, Japan scientist Norio Yamaguchi, actually he first time used the nano word in their word. After that, Professor Dixter used the nano word in their one book. Nano word started after 1974 by Japan scientists. So now Feynman was imagined in 1959, and today you can see what they had imagined in 1959 and what is the progress of that particular research area in today. We can say he has imagined electrical motor size of fingernail. Now, first nanoscale motor was designed by Jet company in 2003. Now, write the entire 24 volume of the Encyclopedia Britannica on ahead. Now, the first page of Charles Dickens. So, man, whatever he has thinking and imagine researching in 1959, now that research area now is going to true in our research, in future research and all. So now you know that nano robotics, whatever people are thinking now, nano robotics are also research area is going to true somewhere, because nano can be comes to your human body to make a operate your suppose cancer cell or suppose any disease. Nano particle will be go there as a type of robotic, and it can be operated at your system. And similar way, whatever research now, so like in electrical Moore's law, a very famous law, actually he assumed that 30% decrease in the size of printed dimension every 2 years. So now you can see that every instrument, like in electronics application, you can also see nano electronics, that is many people, nano transistor are there, nano signals are, nano antennas are there, a lot of things which have a small size and shape will be there. So we can assume every year 30% decrease in the size of printed dimension every 2 years are happening. It was the Moore's law. So now I am coming to very important basic definition of the nano. Okay, how we can define what is the nano science? Only saying that nano is 10 to the power minus 9 meter real region is not true, because you can say at least one dimension should be in nano. Means suppose there are 3 dimensions in any particle, at least one dimension, if I have 1 to 100 nanometer, we can use nanometer. So nanophysics, you can say, is a study of object which have size between 1 to 100 nanometer in at least one dimension. It means that if 2 dimension is not nanometer but one dimension is nano, still we can say it nano. Like in nano rod, it can be one dimension can be in micron region, but one dimension can be in nano, so we call it nano. So we can see lower limit of 1 nanometer is 10 angstrom, correspond to atomic size of small molecular cluster, and upper limit is not precisely defined. Means sometimes we cannot define the, suppose nanometer range, you can say 10 to 200 nanometer in basically, but upper limit is not defined. Sometimes 250, sometimes 400, 300 nanometer can be also comes into consideration as nanoparticle. So the size is typically 100 nanometer is 0.1 micrometer. So there is a quantum confinement of electrons on this side. So what is the quantum confinement? We can define your particle in terms of quantum. So basically how the properties change. When material, suppose any material, I am talking about carbon. Carbon generally find in graphite in bulk form and diamond. In graphite is the generally source of your carbon nanoparticle. So carbon in bulk form is formed in a graphite. Now suppose graphite shrink into nanoscale. Then what happens? How the property will change drastically? And this can be explained by larger increased surface area to volume ratio. Why nano is important? Because surface to volume ratio is increased. Basically, surface area is increased upon changing the nanometer range. I will give you some presentation. You can understand why the surface area is changing and why the activity of nanometal will be changing. And you can say larger ratio gives rise to new quantum mechanical effect. For example, electronic properties of many solids are altered when they reach nanoscale. Not only electronic property, even optical, magnetic, and electrical property will be altered. Also, nanoparticle shape and size affect their property. Even you know that color, you can see if we have successfully synthesized cadmium sulfide semiconductor nanoparticle, if 2 nanometer size will be there, its color will be different. But 6 nanometer color will be different. Means all the type and size will be changed by and can be characterized by UV visual absorption spectroscopy character. So some example of property change you can see. Suppose copper. Copper at micro scale, like in bulk level, copper metal is opaque in nature. But when you design, when you synthesize this copper in nanoscale regime, it can be transparent. So means suppose in smaller size, when you want to utilize the application of copper as a transparent level, so you can apply this. Platinum in bulk level is inert, but when size will be nanometer and it can be catalytic. It means nano platinum can be used as a catalytic application. Generally, platinum also played a very important role, platinum nanoparticle in catalytic behavior of lithium-ion batteries or any electrolyte types of battery, like hydrogen evolution reaction. So simply aluminum material is stable in micro level, and but micron or nanoscale level it can be common. Like gold, gold you can know that it is solid at room temperature. That is your chloruric acid will be source of your material of the gold nano, but it can be liquid at room temperature. That's why we call it nanocolloids or gold nanoparticle in nanocolloid. Nanocolloid means these metal nanoparticles are present in liquid form. That's why we call it nanocolloid. So now this gold nanoparticle have a lot of application in biological importance application or drug nano delivery or many. So now silicon is insulator, but it conductor in nanoscale. So now taking the advantage of conducting properties of silicon and nanoscale, you can make various types of silicon property. So this is the property, whatever can change, shape and size will be affected. So what is the important? Now structural features are between atoms and bulk. Properties are significantly different from bulk material due to large fraction of surface atom, large surface area to volume, high surface area, spatial confinement like quantum confinement. So what is the quantum confinement? That is, if your incident light or wavelength of your material will be less than your L, we call it quantum confinement. Maybe in next slide I will show it will be more clear. So properties of nanometal, it is a very common properties. Everybody know about that. So I am asking this property about the. So I am interested to explain about the quantum confinement, because generally in more scientific way, what is the nano? More scientific way we can define this way. If L is equal to or smaller than lambda value, this regime is known as nano quantum confinement. What is the quantum confinement? You can observe when the size L of your material is of the same magnitude at the de Broglie wavelength, means lambda is equal to h upon p of your electron wave function. If L is less than or equal to this lambda, this can be defined condition is known as quantum confinement. And more properly, you can say this is the nano. Hello, hello, hello. Any problem?
Is any participant having any query? Please keep your mic on mute till the session is going on. You can ask your question answers at the end of the session. Thank you. So please continue.
Okay. So you can see if L is less than or equal to lambda, you can define the quantum confinement effect. And now you can find the when material are this small, their electronic and optical properties deviate substantially from the bulk material. Means you can say that this confining dimension decreases and reaches a certain limit. Typically, in nanoscale, the energy spectrum turns to discrete, because in bulk level, your energy spectrum can be continuous density of state. But when we change the size from bulk to nano, their discrete energy level can be formed. So as a result, band gap becomes size dependent. You know that in any semiconductor depend on band gap. Similar way, by nano regime, you can change the band gap and change the correlate with the band gap with the nanometer. So generally, this is a quantum confinement, and by density of state, by statistical mechanics or physics, you can find the number of density of state in terms of statistical mechanics. So bulk level, nano sheet, nano wire, nano dot. can be defined as 0-dimensional, 1-dimensional, 2-dimensional, and 3-dimensional material. In more complexity, I will show the next slide how the quantum confinement effect can be divided the types of material. Means how you can define 0-dimensional, 1-dimensional, 2-dimensional material, and 3-dimensional material. So before coming to this, you can see surface to volume ratio will be increased in the case of nanoscience. So what is the surface to volume? If suppose we are talking about nanosphere, that surface area will be r square, r is the diameter, and volume can be defined by r into cube, r into r into r, that is r cube. So we can calculate what is the surface to volume ratio, that is r square upon r cube, means 1 by r. So we can say a nanometal have a larger surface to volume ratio. That's why we call it first line why nano dimension is important, because of this surface to volume ratio is increased. So now properties of nano due to quantum confinement effect, nanoscale, the properties of nanomaterials are in general different from the bulk material. So how you can think about this property? Let us see by some example how the surface area at the nanoscale is increasing.
Sound Indian Singh.
Participants, please keep your mic on mute. So wait a second, I will mute.
Okay. So let us see by some example how surface area at the nanoscale will be increased. By this definition, you can understand why the nanoscience regime is important. Suppose we are taking a 1 centimeter cube, that is 1 centimeter cube. If you calculate the surface area of this 1 centimeter cube, it's 6 centimeter inwards because it is cube. Now suppose we are going to cut 1 nanometer cube from this larger bulk material. Suppose this is 1 centimeter cube is a bulk material. Now we have cut 1 millimeter cube from this surface. 1 millimeter cube will be cut. Now you can say total surface area will be increasing here from suppose 1 nanometer cube. That is white region shows the surface area in 1 millimeter. Now what happens if you are talking about 1 nanometer cutting cube from this bulk level? Now you can see that this surface area is increased a lot. So we can say that when we come from the bulk to nano regime, the surface property, you can see here from the diagram, this surface activity is increased. Because of this simple example, you can say due to surface to volume ratio, surface activities of your nanomaterial is highly increased. That's why nano regime is very, very important in scientific and technological application. You can see this is the surface area 60 centimeter in 1 millimeter cube, but when we come in nanometer range, 1 nanometer range, this surface area is highly significantly increased. That's why this regime is increased. So this is a similar example of how surface area scales are changes in case of example of some single particle or 8 particles, how the surface area will be changed. So I will skip the problem because it is the same concept whatever I have explained in the earlier slide. And how the particle size affect the surface area, we have plotted a graph. You can see particle radius in meter and total surface area will be there. So how surface area changes by changing the diameter, we can find out the. So how this smallness lead to new properties? You can say this is a bulk gold, simpler gold. Whatever you wear the gold in the market or you see the gold in the market, that is gold is bulk gold. But when we talk about the gold nano form in colloidal form, then the beautiful color, this magenta color gold nanoparticle will be there. We call it sometimes colloid. Colloid means presence of metal nanoparticle in liquid form is known as colloid. So you can see that here color will be changed, shape will be changed, size will be changed. And this nanoparticle, actually metal nanoparticle is still present in this liquid form. When you drop past of this nanocolloid and glass slide and you take the electron microscopy data, same and same data, then you can see that there will be various shape and size of nanometal will be there. So this is the bulk and this is the nano. Similar way, this is bulk aluminum nanostone. So the simpler way, the gold nanoparticle example, suppose size is suppose 100 nanometer, 50 nanometer, 20 nanometer, 10 nanometer, 5 nanometer. So we can correlate the size and shape and the color. This color is changed about the size and size. It means that after synthesis of any nanomaterial, ultraviolet visible absorption spectroscopy clear give the information about your shape and size before coming to the electron microscopy. Means when I will come in characterization part, then you will understand. First task is our to synthesis the gold nanomaterial. Suppose now its color will be this one, now smaller color this one, now smaller color one this one. Means every shape and size will be different color. Means different color means that first task before coming to electron microscopy, you can simply take the UV visible absorption spectroscopy. And using the UV visual absorption spectroscopy, you will be ensure that whether we have successfully synthesis spherical particle or rod particle or 50 nanoparticle or 100 nanoparticle can be especially characterized by UV visual absorption spectroscopy. Why? Because different color will be changed. So after clarity about your nanoparticle synthesis, after UV visual absorption, because UV visual absorption is a very simple technique, 8 to 10 lakh technique, and electron microscopic techniques are costly technique in range of 1 crore equipment. So means before coming to the same and TEM or XRD, you can ensure that whether you are successful synthesis in certain range or not by UV visual absorption spectroscopy, because different shape and size material will come at particular like spherical gold nanoparticle about 50 nanometer range will come at 550 nanometer absorption peak in UV. And suppose its size is smaller from 50 to 20, that particular 550 nanometer can be at lower wavelength like 500 nanometer. So by finding that particular absorption peak in UV, you will be ensure that we are successful synthesis the nanorod or nanosphere in particular shape and size. Further, you can go to electron microscopy. Simpler way, this is the same and same image for different shape of silver nanoparticles, and you can see the color will be different and the shape is also different. Like silver nanoprism will be 100 nanometer electron microscopy image, and a gold sphere, and this color with 100 nanometer will be sphere and edge sphere. So now I think it is a simple example of various material. Like you can see that this is a bulk gold, but in case of spherical nanoparticle of gold, this is color, this nano rod, this is a larger size shape. Now size of that particular rod can be increased. The particular color will be also. If color is changing, it means that UV visual absorption peak will be also certainly changed, and you can characterize that particular nanometal using UV visual absorption. So this is the quantum dot confinement of quantum wire, nanowire, carbon-based nanowire, various is scanning electron microscopy image after synthesis of your material you can characterize. So in finally we can classify the nanomaterial in 3 parts. Depending on their number of direction in which we get classical and nano behavior, we can define 3 types of nanomaterial. Generally, zero-dimensional material. Generally, zero-dimensional material is your buckyball. Buckyball means that is football. Football like type carbon-based nanomaterial is known as buckyball. Also, it is known as C60 carbon atom. So this football type space, shape, and size in nanomaterial regime is known as zero-dimensional material. And one-dimensional material example, that is nano in 2-dimensional classical. That is carbon nanotube and polymer. Carbon nanotube, you can say it is known as one-dimensional material. And 2D material, that is known as 2-dimensional material, example of graphene. That is single layer of graphene. Single layer of graphite is known as graphene. So graphene is 2D material. And 3D material is your bulk material. It is not nano. So depends on your quantum confinement. Your every nanomaterial can be find out either zero-dimensional, one-dimensional, 2-dimensional, and 3-dimensional is already bulk material. So this is the application of nanomaterial. It is the common application in every research area. So I am not coming to application in particular way. Now I am coming to synthetic part of the nanomaterial. How we can synthesize the nanomaterial? So generally there are 2 categories to synthesize the nanomaterial. By method of preparing, it can be classified in 2 parts. First part is known as top-down process, and second process is known as bottom-up. By name, it is clear. Top-down means top means large and down means small. Means if any larger particle crushed into a small particle in nanoform, we call it top-down process. Means your bulk material, suppose you are going to make gold nanoparticle, means gold nanoparticle will be synthesized from any bulk material like HAUCl4, chlororic acid. HAUCl4, this is a salt, metal salt. Now it is a bulk form. Now when you synthesize in nano form, this bulk material will be crushed into smaller fine particles. So this actually this is not top down. That is chemical route synthesis, what the bottom up. But top down means if suppose chromium, cobalt, nickel, larger type of material bulk level will be crushed into smaller particle, we call it top down. Like in ball milling method. In ball milling method, various carbide or silicon carbide ball are present there, and iron, cobalt, nickel, bulk level material will be comes to that particular ball milling organization. And when you just grill that particular material into smaller particle, we call it top down, because of larger material to smaller particle will become. Actually, generally industry are using to make a bulk level in few kg or few kilograms of nanomaterial using ball milling method. And laser ablation method is also top-down method where your bulk material can be crushed into small particles. Sputtering, arc plasma, electron beam, and photolithography all are techniques. And in bottom-up approach, generally chemical route to synthesis of nanomaterial are using the bottom-up. Bottom-up means bottom means small and up means large. It means that from smallest to larger you are going. So if we are talking about chloruric acid like HAUCl4 as a metal salt to make the gold nanoparticle, now if you just mix a reducing agent in chloruric acid, now you are going to change the size from small to larger, because you know that atom size in some micron, 10 to the minus 10 meter. And now many atoms are collect together, make a nucleate, and further it will be growth in particular direction. It is the bottom up approach, because atom will come there. Atom will come there and make a nucleate and make a nanoparticle. And suppose your nanoparticle is 50 nanometer, that it means that a lot of atoms collide together and make the nanoparticle. This type of process known as bottom up process. So generally chemical vapor deposition, sol gel method, electro deposition method involve the bottom up process. This is the diagram. You can understand. Top down means this is a bulk material which will be crushed into smaller particles. You can understand the ball milling method. Simple example, like in our home, there is some grinder. You generally mix the masala, स्पाइसी मसाला इन योर ग्रिंडर, तो आप ग्रिंडर में देते हैं, आप उसमें मसाला डालते हैं, ग्रिंडर चलाते हैं और बल्क लेवल को आपको मसाला नैनो पार्टिकल टाइप में मिलता है. तो दिस इज एग्जांपल ऑफ टॉप डाउन. सिमिलर कॉन्सेप्ट बॉल मिलिंग मेथड एक्चुअली यूज द बल्क मटेरियल इनटू पाउडर फॉर्म ऑफ दैट इज टॉप एंड मेक द नैनो पार्टिकल. एंड इन अपोजिट इन bottom up, atomic construction come together and make the clusters of the nanoparticle. That's why we call it bottom up approach. So all the nanoparticle can be confined in. So I am not coming to particular part of the synthesis of, because my motivation to come now research part also, because it was the basic fundamental part of our nano part. So we can see that I have stabilized the very basic part here, ki which types of synthetic protocol use which type. Like arc discharge method to synthesize nanoparticle is a top down. What is the temperature range, what is the inert, what is the pressure, voltage control, quality, quantity is given in everything. Like laser ablation method, it is top down method, and what would be the pressure and what would be the other parameter it is involved. And ball milling method, it is a top down, room temperature is required, and what is the RPM required, and how types of nanoparticle can be involved. Sol gel method, like metal oxide nanoparticle generally synthesized by this chemical route method. This is a chemical route method, that's why we call it bottom up approach. And here we can calculate CVD, chemical vapor deposition, electron deposition method, all our method are involved, and it is already well documented in the literature. For particular shape and size of nanometal synthesis, you can adopt any particular region and any particular synthetic protocol, and by reading the literature, you can simply make the particular nanomaterial in your particular range. So I am not coming the more detail about the synthesis of particular material. So after synthesis of nanomaterial, second part you need to characterize the nanomaterial. Since nanomaterial is in the 10 to minus 9 meter region, that's why microscopy means microscopy will not helpful to characterize the nanomaterial. Even you know that from our blood sample, bacteria or antibacteria, everything can be controlled or can be characterized by microscopy, optical microscopy. But nanometer dimension not be characterized due to resolution problem about the microscope. That's why electron microscopy is highly required. In electron microscopy, you know that electron will work as a wave nature, because you know that according to de Broglie hypothesis, lambda is equal to h upon p. Now your electron, which is a particle, it will also behave as a wave. Now if electron behave as a wave, now if after synthesis your nanomaterial comes to the specimen of your carbon grid, after synthesis of nanomaterial, now electrons will impedant on that particular surface, and using some optical lens or electromagnetic lenses, you can control their shape and size, and you can characterize their morphology using electron microscopy, like scanning electron microscopy for various morphologies, and TEM, transmission electron microscopy, to characterize your shape and size. But first part, immediately after synthesis of your nanomaterial, UV visual absorption spectroscopy is first step to characterize your nanomaterial. Because SEM and TEM is costly equipment, using UV visual absorption spectroscopy, you can get a certain peak, absorption peak in particular range. Suppose you have synthesized 50 nanometer peak in gold nanoparticle, immediately take the UV visual absorption spectroscopy. Then if gold nanoparticle will be there, 550 nanometer, you will get a absorption peak in UV visible. Then if you, now you can go electron microscopy, then you will find that similar spherical types of nanomaterial will be formed. And this types of example I am going to share you from my one published research work. Then you will be benefited how synthesis of gold nanoparticle can be characterized by UV, can be characterized by SAM, TAM, and how you can apply this nanoparticle for the research area and application. So overall, you can characterize after synthesis of material, structural characterization, optical characterization, electrical characterization, and magnetic characterization. In a morphology, optical microscope like SAM, TAM, electron microscopy, you can calculate. Scanning tunneling microscope. So further, few people are focused on the crystallinity behavior of your nanomaterial. How your material is, what type of crystallinity, like 111 plane, 100 plane, 200 plane. This type of crystallinity behavior can be explained by X-ray diffraction technique, XRD, which based on the this XRD based on the Bragg's law. 2D sin theta is equal to L lambda, where in x-axis you are getting 2 theta versus intensity. The 2 theta means every angle of the crystallinity plane will diffracted at some different angle. Like gold nanoparticle, if you are getting 111 plane at 32 degree, there you will ensure that our gold nanoparticle in crystalline nature in face-centered cubic structure. Similar way, zinc oxide, copper oxide, or titanium oxide, every nanomaterial have few crystallinity behavior. Like in titanium oxide, rutile phase or anatase phase, you can control or you can characterize by XRD techniques by identification by 2 theta p. And you can control, you can understand that whether our peak is rutile phase or anatase phase in titanium oxide. Similar way, every nanometal can be characterized crystallinity behavior by X-ray. So various techniques like X-ray photoelectron spectroscopy and optical properties can be defined by UV visible or Raman spectroscopy. That is structural part also can be defined where your ligand is interacted with nanoparticle at which place. Then electrical property, magnetic property can be characterized. So after understanding this fundamental part of nanoscience, nanotechnology, and synthetic protocol of bottom up and top down, now I am coming to part of various kind of nanomaterial. First part I will start from the metal nanoparticle because it is the simplest part of our nanomaterial. So metal nanoparticle, why nanoparticle is important? Like copper, gold, silver, platinum, aluminium. This is the bulk level material. How we can synthesis in nano form, and why we are going to nano form, and why we can go to implement in various research applications. Let us see. So like metal nanoparticles have various applications like therapeutic agent like gold nanoparticle in therapy, in cancer therapy, and various therapy in order to define or in order to cure the tumor in various research, nanoelectronic probes, sensors, diagnostic, catalysis, a lot of application of this metal type nanomaterial. Basically, today I will show from my research work how the metal nanoparticles are important in sensing the explosive material. Explosive means RDF, TNT, uranium material, and some hazardous element from the environment in the nanomolar concentration or picomolar concentration. Even one dust particle can be analyzed by this nanomaterial. I will show in the last part of our lecture. So synthesis of gold nanoparticle. Suppose now I am talking about gold nanoparticle. How you can synthesis using general chemical route? Actually, nanoparticle can be also synthesized various routes like physical method, UV radiation, laser ablation method, plasma synthesis. Chemical route, that is citrate synthesis, weight chemical method, chemical reduction method, and physiochemical route, that is sonoelectrochemical method. But I am going to discuss about the chemical route because chemical route is very easy and fast method compared to other method. Because in suppose physical method, laser ablation is some costly equipment. You need some laser light which are costly 10 lakhs or 12 lakh laser light to synthesize the nanomaterial. But in chemical route, you have very little effort to synthesize your nanomaterial. Like suppose gold nanoparticle you are going to make, it means that you need some salt. Salt of the source of gold nanoparticle is chloruric acid, HAUCl4. That is metal salt is available in the market. You have to purchase it. And now reducing agent, either sodium borohydrate, NaBH4, or citric acid, sodium tricitrate, you have to mix in concentration. Like, and after this beaker, you can see HAUCl4 solution, aqueous solution, and you have now mixing the reducing agent in terms of here by drop wise. You can say by drop wise mixing in these things, magnetic stirrer, that will magnetic heater stirrer will running, and 10 millimeter of fluoruric acid was dissolved in 100 ml of deionized water, and you can see that after certain times of 1 hour or 15 minutes and dispersion where you will find the dark red solution, because generally yellow color, generally metal salt is yellow color powder form, but when you dissolve and make this reducing agent, after certain time you giving the stirring, the color will be reduced, color will be changed from yellow color to red color. So now immediately you can show your HAUCl4 particle will be reduced in the nano form. That's why we call it bottom up, because smaller atom will collect together and make the nano form. We call it nano collide. So this red color have been synthesized after apply the dispersion where you can centrifuge your this particle, means larger particle will be collected down on supernatant solutions you can take from the above, and you can, this will be after 14,000 rpm you are getting the nanoparticle in the metal. Nanoparticle means gold metal particle in liquid form, we call it nano collide. And now second approach, you can immediately take the UV visual absorption spectroscopy, and suppose you want to make nano rod type structure, then 700 or 730 nanometer peak you will get in UV. Then you will be ensured that we have successful to synthesis nano rod. And if you want to make gold nanoparticle or gold nanosphere, a triangle, different shape and UV visual absorption peak will be comes in your UV visual. After clarify, after UV visual, then you can proceed for electron microscopy. Electron microscopy means you have to need carbon grid, and you need to some effort to carbon. This liquid you can drop casted and you can take the electron microscopy. And after understanding the different shape and size of your nanomaterial, further you can utilize this nanomaterial for various applications. Now in catalytic problem or cancer, in anti-cancer drug, you can mix this nanoparticle for enhance the activity, or you can mix this gold nanoparticle for diagnostic process or sensing property of particular material and various research field. So this is the basic general approach to synthesis of nanomaterial of gold. Similar way, any metal nanoparticle you can design, but only change is that instead of this metal salt of HAUCl4, just you have to take that particular metal salt. Like silver nanoparticle, you need here AgCl. Silver chloride salt from the market you can purchase, and the same protocol you can follow. And same UV and characterization technique you can follow out. And XRD, if you want to crystallity behavior of your material, nanomaterial, like face-centered cubic structure, you can apply the X-ray diffraction technique, and you will find certain peak, and you will ensure that our nanometal is crystalline behavior. So now biosynthesis of gold, that's what the chemical route. Now many people can be used physical method, biological method, and electro or hybrid method to synthesis of nanomaterial. Like suppose biological synthesis of nanomaterial means that instead of here sodium borohydrate or sodium citrate, people are using generally many biomolecules. Any like botany people can be used neem, aloe vera, या kali mirch, garlic, black pepper, whatever people generally use this types of leaf extract to synthesis the nanomaterial. उसमें क्या करते हैं? Direct metal salt they have used, and now reducing agent they have directly used curcumin like haldi. They have used haldi or leaf extract, neem, aloe vera, tulsi, garlic, any material they have just mixed with that particular metal salt, and they have synthesized the gold nanomaterial. Why biological seed? Because they are taking the advantage of both. Because gold nanoparticle have very less toxic and very important biomedical application. So it means that suppose agar haldi बहुत important है, now if using the haldi you are synthesis nanomaterial, so now you are utilizing the both, mixing of gold nanoparticle importance and mixing application of the gold. That's why now people are interested to make the gold nanoparticle, silver nanoparticle using directly from the biomolecules or herbal molecule or any leaf extract. So by approach is simple. Similar way, you have just mixed simpler way whatever I have explained. And you can see by UV visual absorption spectroscopy certain thing, you can take the electron microscopy, this types of shape and size will be looked at. And XRD, you are getting 2 theta versus intensity. And 2 theta you can see, suppose it is gold nanoparticle, face-centered cubic structure, this 111 plane, that is HKL, that is diffraction technique, HKL diffraction technique. So at 111 plane, you will find the highest peak in the X-ray diffraction technique. Means 39-degree peak. If you are getting in XRD for any particular gold nanomaterial, you are ensured that we have successfully synthesized the face-centered cubic structure, which have crystality behavior. Further, in electron microscopy, also you can show the crystality behavior of this nanomaterial using scanning area electron diffraction, that is SAED pattern. So now, after understanding this basic part, now I am going to present my research work, which was published in Nanoscale. Here we have shown that nucleation and growth of antibiotic labeled gold nanoparticle. Further, we have tuned the gold nanoparticle size from the 20 nanometer to gold quantum cluster size. So I will differentiate what is the nanoparticle, what is the quantum cluster, how we can differentiate the nanoparticle to quantum cluster, and further how we have applied this synthesized gold quantum cluster to sense the mercury ions in cell also and in drinking water also. Means this gold quantum clusters are presented here as a sensor of the mercury ion, because mercury is a very hazardous element. By accumulation of the water or by accumulation of the food in our human body, it can cause the liver cancer or kidney cancer. So means according to WHO, World Health Organization, the maximum lowest amount of mercury ions can be permissible in our body in terms of some micron level. But 2 nanometer mercury ions can be detected in our published research work, which was published in Nanoscale. So whatever we have used, actually I am going to explain about the complete picture of synthesis, characterizations, and particular application. So all these three parts are included in this work. So let us see. First of things, why we have used antibiotic. Antibiotic molecule, this is a drug molecule, cefadroxil or cefadrin. So cefadrin molecule is an antibiotic molecule. We have just purchased it from the market, pharmaceutical industry. Now this cefadrin molecule has some chemical molecule, that is chemical structure. Now we have seen that in the last part of the PPT, how we have synthesized gold nanoparticle, that is HiUCl4 plus reducing agent. Here, instead of reducing agent sodium borohydrate or sodium citrate, we have directly mixed the antibiotic in order to synthesize the nanomaterial. Let us see how. So antimicrobial, why we have taken antibiotic molecule? Because antibiotic molecule, you know that is three types of antibiotic: antimicrobial and disinfectant, antiseptic, antibiotic. Antibiotic means that will kill the bacteria in our human body. Antiseptic, generally it is also antibiotic, which are generally used to in order to cure the before the operation at the surface of the skin. Generally antiseptic creams are used. The antibiotic we have used, why antibiotic is important? Because it is non-toxic. And what is the problem? Actually, antibiotics area, research area, what is the problem? Problem is that nowadays bacteria are getting the resistance with antibiotic. Means whatever bacteria is there, now they are compatible. They're making it compatible to antibiotic. Means the dose of antibiotic is not very effective against the gram-positive and gram-negative bacteria. So means what is the problem? Because now, right now, we are facing the problem of coronavirus. Coronavirus even not much dangerous compared to any strong bacterial infection. So now this problem is that bacteria getting the resistance against the antibiotic. So now people are interested to make a research such a way that using the nanotechnology, how we can enhance the properties of antibiotic molecule and come less dose of the antibiotic can be there. So many people are using many research area in various way. Sometimes generally antibiotic properties are coming from beta-lactam antibiotic ring. Beta-lactam is a ring which are responsible to kill the bacteria in antibiotic molecule. So many people generally modified the beta-lactam ring. Few people are making new types of antibiotic generation new. Few people are combined two types of antibiotic molecule to kill the bacteria. Few people are combination of antibiotic with antibiotic drugs. And now few people are making mixing up nanoparticle or polymer nanoparticle with antibiotic molecule. And now they want to kill the bacteria. Because in future, it would be also very important to design many new types of antibiotic. Because now you can see the mosquito. In sometimes winter mosquitoes are running around the fan, because now mosquitoes are also develop the compatibility with that particular environment of winter. So sometimes you can see that all out is running there, but mosquitoes is still running about in here and there. So means mosquito also running there, giving a compatibility about that. Similar way, now every bacteria got the resistance against antibiotic. So now it is highly required to make to kill the antibacterial in a very effective way. So in this problem, that's why we have taken the advantage of antibiotic molecule and gold nanoparticle. So we have synthesized gold nanoparticle directly using the help of antibiotic molecule without adding any extra term. You can see that Why gold nanoparticle we have taken? Because you know that gold nanoparticle is very small, surface to area volume ratio is increasing, polyvalent molecule. You can say that mostly used nanoparticle is biocompatible, and it is less toxic, and it's providing the greater stability to your biomolecules and our human body. That's why gold nanoparticle has been used. You can see here gold nanoparticle is due to the tunable size, because by changing the shape and size, you can change the properties and you can take the advantage of tunability of the size and size of your gold nanoparticle. And is biocompatible. It is compatible to our human body, less toxic, surface modification of this particular lead drug molecule, and surface functionalization of gold nanoparticle with that particular drug molecules is very easy. That's why. And different sphere and rod is nano cage you can synthesis in various part. So before coming to this research work, I want to differentiate two terminology. It is very important. Nanoparticle and quantum clusters. Nanoparticle, you know that actually size 10 to 100 nanometer generally we call it nanoparticle. Means particle of size comparable to electron mean free path. That is 50 nanometer for golden. But quantum clusters, sometimes some people are using it nano cluster, but exact word is quantum cluster. Quantum cluster is that when your size of your particle with less than, or you can say it will be comparable to electron wavelength of Fermi energy wavelength, that is 0.5 nanometer for golden silver, we call it quantum cluster. Quantum cluster means that below to 2 nanometer range, particle below to 2 nanometer, it will show the quantum cluster type behavior, where Fermi wavelength of electron is comparable to this. Why it is important? Because below to 2 nanometer of the size of any metal nanoparticle, it is known as metal quantum cluster, and it will show the size dependent fluorescence property. Overall, you can say that if 10 nanometer, only few number of clusters will be there. In 50 nanometer, you can assume more than 10,000 of gold atoms or nanometers are involved. But in gold quantum cluster, only few limited number of atoms will be there, like gold 8 quantum cluster, gold 25 quantum cluster, gold 108 quantum, 108 quantum cluster. So this quantable known as quantum cluster. So actually this quantum cluster is a very highly hot topic of research nowadays. Means people are interested to make quantum cluster, means size below to 2 nanometer. And you can see this nanoparticle is face-centered cubic cluster, but is non-crystalline below to 2 nanometer. And now strong covalent bonding, but big. So because in this work I will show the combined particle nanoparticle, and I will also show how we have find very interesting result using quantum cluster, and how this quantum cluster means only 8 gold quantum cluster apply to sense the various things. So this is our starting part of the work. Whatever we have taken the HAUCl4 from the market, that is metal salt, that is base of the metal salt HAUCl4, chloruric acid. In HAUCl4, gold have +3 ions, because H is +1, Cl4 means -4, means gold have +3 charge. So in HAUCl4, just we have mixed the antibiotic molecule. This is the cypradine antibiotic molecule. In antibiotic molecule, this region is on beta lactam. This chloruric acid in aqueous solution, and you have further soda that steering magnetic stirrer for few minutes, and directly without mixing any other element, you have synthesized the gold nanomaterial. And now this is the showing the cypradine conjugated gold nanomaterial. This yellow part is your gold nanomaterial, and this black part is showing that your gold nanomaterial is capped by your antibiotic molecule. So this is the important. And now you can utilize these types of nanomaterial for further application of antibacterial or कैसे? Now antibacterial antibiotic molecule have still bacterial application. Now gold have still. Now gold is applicable here and antibiotic is applicable as a surface ligand. So now you can advantage of both materials simultaneously. Now this antibiotic will give stability, chemical stability to your gold nanoparticle. And still any small element of your cypradine antibiotic capped gold nanoparticle can be helpful to nano drug delivery or kill the bacteria. Let us see why it is important. Because it is simple one-step process. You don't need make any extra effort. In our simple laboratory, you can make this within 10 minutes. You can make the antibiotic labeled or antibiotic labeled gold nanoparticle. And non-bulky and very small element molecular ligand has been required. A small amount of antibiotic required, like 10 to -3 molar or 10 - 6 molar concentration of antibiotic. It is very economic because very low, because antibiotic molecule, you know that very less economical effort you can. And you can tune now. You can tune the nanoparticle size and nanocluster. How, let us see. In this work, we have applied both UV visible, after synthesis, UV visible, scanning electron microscopy, and various techniques we have used. After synthesis of gold nanoparticle using directly antibiotic, first step we have applied UV visual absorption spectroscopy. So let us see this diagram showing the UV visual absorption spectroscopy, that is x-axis, y-axis, in wavelength and versus absorption. So now you can see that we have started from 10 to the power minus 4 molar concentration. From here now we are going from 10 to the minus 4 from bottom to top, that is blue one is 10 minus 3 molar concentration. Now after synthesis of gold nanoparticle, after taking the UV visible, you can see a sharp peak is observed at 550 or 580 nanometer. If 580 nanometer this peak are coming, it means that we are ensured that we have successful synthesis of almost polydispersed spherical types of nanomaterial. And immediately if we take the electron microscopy, transmission electron microscopy image at particular area with UV and TEM, you can correlate here. Suppose this is 10 to the minus 4 molar concentration and here 10 minus 4 molar concentration. You can see if you compare spherical types of nanomaterial will be there. And suppose if you are changing the concentration or increasing the concentration from 10 minus 4 to 10 minus 3 molar concentration, anisotropic concentration.
Cap is mounted on the top of the pitch. Then this same container is covered with a leak-proof cover made of cardboard. So in the cell, the carbon rod or the carbon rod starts the process only, and the fuel container across the.
Hello, actually.
Yes, sir. Wait a second. I am seeing somebody has unmuted, I think.
What is the question, Sanju? Actually, her voice is not clear to me.
Ma'am, can you please repeat?
Can you drop the message? It will be more easily. Because
Yes.
your voice is not clear. What do you want?
The participants, is there any query? Please post in the chat box. I will read it out. I think. Wait a second, sir.
Okay, in the meantime, you can give the chat box and I will collect all the questions. And last 10 minutes, I will answer all the questions. Okay?
Okay, sir. Okay.
So now you can see that after taking the UV visual, now TEM is directly connected to that particular part of the thing. Like suppose we are focused on this blue part, here anisotropic nanoparticles are also there because this is NIR region. In this NIR region, if absorptions comes, we can say that nano rod particles will be also there. Particular things you can see here. Now, if you increase the temperature, now let us see the nucleation, how you can control the temperature and particle size. And now you have increased the temperature of your sample, prepared sample, now from 10 degree to 50 degree. You can see here, the red one showing the 50 degree, means larger temperature. At the larger temperature, you can see that this anisotropic means this NIR region peak at 1000, more than 1000 nanometer peak is not observed. It means that at higher temperature, nucleation is much more fast and you will find the more spherical particle. But when we decrease the temperature from 50 to 10 degree, means upper part, that is top part, this brown spectrum, UV visible spectrum, you can see that in NIR region, a hump absorption peak are coming here. It means that if you correlate the TEM image of this UV visible here, then in TEM image, you are seeing that there is triangle types of, means non-isotropic particles are also formed during the synthesis of antibiotic level gold nanoparticle. You can see that because it is directly connected to here. 50 degree, no peak in NIR region, means only spherical, dominant of the spherical peaks are there. But in this part, only triangle peaks along with spherical parts are also coming, where you can see UV visible and TEM are directly connected. And one more conclusion you can draw from that higher concentration of your molecule, concentration showing the anisotropic property, and higher temperature showing here spherical particle, and lower temperature showing the triangle types of nanoparticle. Why? Because slowing the temperature means, giving the lower temperature means that reaction rate of your nanoparticle will be slow. Due to slow kinetics, this growth of your nanoparticle needs much more time, and that's why anisotropic like triangle or nanorod types of structure can be formed. After understanding the synthesis of this gold nanoparticle, we have found a very interesting result when we change the pH of the solution. It was the most interesting result where we got the very high quality of result in terms of quantum clusters. That's why this paper was published in very reputed journal in nanoscale. The impact of this journal was 8.5 at that time. So nanoscale is a very important journal because of the concept as that in this quantum cluster. So actually we had changed the pH of the solution. pH of that particular gold nano solution from 4, 5, 6, and we have found that at particular pH 6, when we change the pH of the solution, then at pH 6 we found that a very small types of particle were obtained in UV, in transmission electron microscopy image. You can see that dot type structure are there. So we have found that if correlate with UV visual absorption spectroscopy, you can say that is blue region at 350 nanometer, this peak is coming. It means that smaller particle generally comes in the lower wave number site of your UV visual. So after getting this pH 6 solution, we are ensured that we are going to synthesize the gold quantum cluster, because below to 2 nanometer we call it gold quantum cluster. Now second things, we need to prove how many gold atoms are present at this pH 6 number of. So in order to provide that your gold antibiotic molecules are binding to gold nanoparticle, we have so the XPS X-ray photoelectron spectroscopy. XPS technique generally shows that where your antibiotic molecules are bind with to gold nanoparticle. So generally in your antibiotic molecule, suppose this is the theoretical calculations also in order to understand the surface capping and binding mechanism. So this is the antibiotic molecule. You can say red one is oxygen, and blue one is nitrogen, and yellow one is sulfur. So you can see that if you mix the gold atom, our gold nanoparticles are mixing with this antibiotic, so it is binding at sulfur gold. It will make a strong covalent bond at sulfur AU. Now we have also checked the binding of gold with various positions like oxygen at beta lactam ring and other carboxylic group. And we found that first, this sulfur reduced means in order to play the role of synthesis of nanoparticle, this sulfur plays an important role, because in chloruric acid gold have +3 charge, but when we mix the gold at sulfur place, gold gets a negative charge in gold nanoparticle, and the reducing property of sulfur is much larger than oxygen. So when we comes in the sulfur part or gold part, we can find out that our antibiotic molecule successfully reduce the size of HAUCl4 in nano form, as well as it bind with sulfur and oxygen, the gold nanoparticle, which stabilize your particle for several months. So how we can prove that we are successful to make the gold 8 quantum cluster below to 2 nanometer at pH 6? Actually, it was the basic main result of our research that at pH 6 we got the gold 8 quantum cluster. Gold 8 quantum cluster showing the fluorescence types of basic property. What is the fluorescence type of basic property? Means that if you take the fluorescence property that is excite this sample at 337 nanometer, we are got the emission peak at 432 nanometer with the Stokes shift of 95 nanometer. And how we can prove that it is gold 8 quantum cluster? You can take the multi-top spectrometer, multi-top mass spectroscopy. You can find out that how many gold atoms are involved in this nano solution. So by multi-top matrix, after that time resolved fluorescence spectroscopy, we have defined that these gold 8 quantum clusters we are successful synthesized. And now how we can apply this gold 8 quantum cluster for antibacterial application and one sensor application. Actually, now this gold 8 quantum cluster, this is the size using the TEM, HR TEM. You can see that. Now we have applied this to sense the mercury ion. You know that mercury is a very hazardous element. By the drinking water, accumulation of mercury ions in our body accumulate very slowly and slowly. After certain years, this cause the liver cancer and various types of cancer in our human body. So this is the highly required to detect the mercury ion in nanomolar concentration. That's why we have applied this gold 8 nanoclusters to detect the mercury ion. How we have to detect? Actually, we have taken bivalent a lot of type of more than 25-30 metal ions and mixed with this fluorescence property of gold 8 quantum cluster. So when we mix 25 types of metal ions, you can see here mercury, cadmium, lead, cerium, nickel, sodium, magnesium, silver, a lot of metal oxide we have mixed with this gold 8 quantum. But there is no any change in that particular emission peak, fluorescence peak up about the pH 8. But as soon as we have mixed mercury ions in that particular sense, that mercury ions fluorescence was quenched. Fluorescence quenched means that we can say now out of this 25 element, this gold 8 quantum cluster plays as important role as a sensor. ये 25 मेटल आयन में से केवल मरकरी को ही सेंस कर लिया. It means it will sense always mercury at particular surface or in nanomolar concentration. If mercury ions is there, if you put gold 8 quantum clusters is there, it will, your fluorescence property, blue fluorescence color property can be quenched, and other metal ions will not affect the fluorescence property of that gold 8 quantum cluster. And you have to find out selective and sensitive detection using by changing the concentration, and we have found that until 2 nanomolar concentration can be collected or sensed by this gold 8 quantum cluster. So we can simply say that our gold 8 quantum clusters using antibiotic molecules are presenting as a sensor of the mercury ion, which are very dangerous and hazardous element for human body. So in order to prove that how this is kill the bacteria sample or not in the presence of antibiotic, we have apply in the cell in the collaboration of some biotechnological persons. We have found that suppose this is the control 0 hour, 12 hour, 24 hour, and this is the pure antibiotic. Pure antibiotic will kill the bacteria after 24 hour by halfway. But after pH 4 or pH 5 or pH 6, you can say that at pH 6, after 24 hours, almost all bacteria will be killed by this antibiotic connected by gold nanoparticle. So this is the importance that small quantity of antibiotic connected to gold nanoparticles clearly kills the old bacteria in very significant way compared to your control antibiotic similar way. Further, this bacteria cell war mercury is also sensed in human body in any cells also. So this is the microscopy image, dark field microscopy image where mercury were detectable by that particular thing. Now in cell, suppose bacteria were grown in the laboratory, and this bacteria shape was characterized by scanning electron microscopy. Now antibiotic labeled gold nanoparticle were incubated in this particular bacterial cell, and you can see that after certain time your bacteria wall is degraded and blebbing here. You can say that is bacteria wall using scanning electron microscopy technique. You can say bacteria wall is degrading, it is breaking after certain type of insertion of gold with nanoparticle with particular antibiotic. So means it shown that also in cell this particular nano combined gold antibiotic molecule are connected for various. Further on this concept, we have also published a US patent. It is published and granted by US. Actually, my colleague and me here, Dheeraj Kumar Singh, Puneet and Pankaj Poddar, actually we three apply this particular small types of concept to find out the gold quantum crystal for various research application. In this particular things, you can see the title of this patent was simple way that one pot process for the preparation of gold quantum crystal. Actually, after getting this paper ideas, we have also worked as a patent in particular another ligand molecule L-cysteine. L-cysteine is a simple amino acid. Using this amino acid, we have synthesized various types of tunability of gold quantum cluster, gold 8, gold 25, and gold. And this idea was published, and you can see that it is published and available in online. You can find out it is very interesting patent. So simply, you can also see this is another paper actually we have published in nanoscale. In this paper, actually, we can say this paper is also published in nanoscale when I was working as a CSIR Nehru postdoc. And nanoscale is a very also again same international research paper where we have shown the synthesis and surface punctuation of gold nanoparticle with curcumin and their anti-cancerous property. Anti-cancerous property. So curcumin, everybody know that. What is the curcumin? Curcumin that is known as turmeric. Curcumin is a part of turmeric that is yellow characteristic part of yellow color showing a lot of application. You know that curcumin haldi अगर आपको घर पे चोट लगती है, people are giving or your parents are giving haldi in your मटेरियल, मिल्क मटेरियल की चोट लगी है हल्दी से दूध मिला दो, चोट लगी है खून बह रहा है आप हल्दी लगा देते हैं. तो व्हाट इज द मीनिंग ऑफ दैट? इट मीन दैट curcumin is a lot of application like anti-tumor, anti-cancer, anti-fungal, antioxidant, antiviral, antibacterial. If you are taking the antiviral fever, then also in haldi you are taking the haldi doodh. Why? Because this curcumin, it is also known as curcumin. It is a part of the curcuminide. So it have all the properties of antibacterial, antiviral, anti-cancer. But so far it is not become a pharmacological drug so far. Why? Because due to poor bioavailability, it does not make a drug molecule so far. So why the people are now interested to make curcumin as a drug molecule, and people want to enhance their bioavailability by different way. Some people are mixing it gold nanoparticles, some people are making in polymer particles, some people are mixing within hot materials, and some gold materials people are using it. So actually we have synthesized here again with same concept. At place of the antibiotic we have used just curcumin molecule. It is available in the market. This curcumin molecule have CH, this red part is oxygen and other part is black part is carbon, and white part is hydrogen. So red part is oxygen, CW bond actually. So now HiUCl4 we have take metal salt, just we have made the curcumin aqueous solution in this part using the magnetic stirrer route. Now after 10 minutes, now your gold nanoparticle has been synthesized, where your curcumin molecule are present as a capping as well as reducing. Means here curcumin act both reducing agent as well as capping agent, and this is the curcumin functionalized gold nanoparticles now. तो येलो पार्ट इज गोल्ड नैनो पार्टिकल. नाउ कुरकुमिन मॉलिक्यूल आर प्रेजेंट, क्योंकि एक नैनो पार्टिकल के ऊपर बहुत सारे कुरकुमिन हल्दी मॉलिक्यूल हैं. दैट्स व्हाई वी curcumin functionalized gold nano particle. Now let us see, after synthesize this curcumin gold nano particle within two step process, our first step to characterize using UV visible. So UV visible we have taken at different concentration, 10.5 to 10.4 molar. Then we have found a 515 nanometer. We got the peak. This peak is coming due to surface plasma resonance of your particular nanomaterial. And you can see that if you take the electron TEM transmission electron microscopy image, you can see that this is correlated with your UV result. And the high resolution TEM, you can see that in this closure examination, look that your curcumin molecule as a organic cells are present near about your gold nanoparticle, because this black one is gold nanoparticle, and this organic contrast difference you can say around this gold nanoparticle or your curcumin molecules are present. So now you have successfully synthesized gold nanoparticle, where gold nanoparticle are capped by your curcumin molecule. Now further you can apply this gold nanoparticle capped with curcumin for anti-cancerous activity. Actually, the capping agent binding mechanism can be approved by fluorescence, because generally curcumin showing the fluorescence at 560 nanometer, but in the presence of gold nanoparticle, this quenching of the fluorescence has been happened, which is clearly indicate that your curcumin is bind with your gold nanoparticle. Now further we have applied that whether it is showing the anti-cancerous activity or not. So in the presence of DPPH antioxidant, actually DPPH is a radical test, which is a fast and rapid test to identify that your whether your molecules or material is antioxidant or anti-cancerous activity have or not. So how you can find DPPH a radical test? DPPH generally showing the absorption, optical density absorption at 515 nanometer in optical density absorption, because of due to substance color. Now suppose if any antibiotic or sorry antioxidant, anti-cancerous activity molecule are interacted or mixing with this DPPH radical, then the absorption of this DPPH peak will be reduced. Means optical density of 5145 will be reduced in the presence of antioxidant, because now it will be oxidized. So now when we mix this curcumin gold nanoparticle in this DPPH, you can see that this absorption peak is 1 in our intensity will be reduced in terms of 5.5 nanometer. So this DPPH radical test shows that in the presence of curcumin, in the presence of gold nanoparticle, it's showing the enhanced antioxidant property, which can be very helpful to understanding which kill the cancerous cell also. So after understanding this, many biological people using the gold nanoparticle, they have utilized this concept, and they are published a lot of research work to kill the cancerous cell using the curcumin in the presence of gold nanoparticle, and they have applied in mouse and something like that. In order to surface functionalization and binding of curcumin with gold, I have applied also some quantum chemical calculation, that is theoretical calculation, and we have found that here, due to the presence, this is a curcumin molecule haldi. There, this red one is oxygen, and this is carbon, and this white is hydrogen. Now, in the presence of gold nanoparticle like this one, this is the intramolecular hydrogen bonding, which is the breakage of intramolecular hydrogen bonding. Is that due to the breakage of intramolecular hydrogen bonding, the bioavailability of curcumin molecule is enhanced, and we have showing the binding of this 3 gold atom to this curcumin molecule, and also homo-LUMO energy transfer from the curcumin or metal ligand to here. How the charge is transferred from the curcumin molecule to the gold quantum gold nanoparticle of this thing. And this is the color wise original charge transfer between the curcumin and gold nanoparticle. So overall, this paper was published in nanoscale due to this application in antioxidant property of curcumin. And so this was the conclusion. Now silver nanoparticle. So now silver gold nanoparticle, you can also understand the basic silver nanoparticle. The criteria is same. So I am not going to repeat about the silver nanoparticle because now I want to come in another type of carbon-based nanometal or metal oxide. But very briefly, I would like to say you that pure silver nanoparticle have various research applications. Pure only silver nanoparticle. What is the cancer therapy, diagnosis, drug delivery, UV protection, nutraceuticals, food packaging, interactive and fuel cell, fuel additive catalysis, water disinfectant, wastewater treatment, UV blocking, medical textile, means a lot of application of silver nanoparticle. And silver nanoparticle, how you can say? You can synthesize silver nanoparticle in same way as we can synthesize the gold nanoparticle. But instead of HAUCl4, now you have to take in the AgCl. And now you can mix the reducing agent for this silver. And if you want to take advantage of any particular biological approach, then you can also apply this. So here, synthesis method of silver nanoparticle are given. Same route, same approach you can synthesize. So now I am coming, various routes are there, chemical route, physical method, biological method. So using green plant extract like aloe vera, yeast, neem, mint, aloe, etc., you can also use to synthesize your nanomaterial. You can show the enhanced activity of your. And the chemical route, simple route, you can take Ag nitrate, silver nitrate, or silver chloride too. Simpler way you can take silver nanoparticle. It is this one. This L-cysteine fungi silver nanoparticle like this way. Yeah, this is the silver nanoparticle where L-cysteine, this is amino acid, are present above the silver nanoparticle like this way. Because amino acid are always present in your drug molecule or any monomer. So now you are taking the advantage of both silver nanoparticle and drug molecule. So you can characterize by UV visual absorption spectroscopy. Now you can say that for 1-2 nanometer shape or size nanometer have absorption peak at 430 nanometer. And when size is below 241 type, you can see that is blue shift in the peak is coming. That is 392 nanometer peak is coming. So means different shape and size of material can have different absorption peak. So you can simple within 2 minutes you can understand your successful synthesis of which type of shape and size using the UV. After that you can apply the various types of same time and characterize. So copper detection using this silver nanometal, copper detection were there in very low concentration. So green synthesis of silver nanoparticle where can be also synthesized using some another biological approach. People are many people. Some people are using neem to synthesis silver nano, aloe vera, Indian mint, guava, whatever people are thinking, black pepper, garlic. People are using synthesis of silver nanoparticle, and they want to show the application of these types of nanoparticle in various regions. So now, simple way, just you have to give the heat, take the 5 gram of leaf, whatever leaf, neem, aloe vera, mango, whatever take, and you can apply these types of. So means a lot of types of silver, and further you can take here like binding XRD mechanism like hexagonal crystal structure by this obtaining this peak in XRD. Surface plasma resonance can be UV, same, tame, and after several days you can see that your silver nanoparticle are still stabilized in the presence of particular ligand. So green synthesis of silver nanoparticle and photocatalytic activity of silver nanoparticle using various precise was given. So I am not coming. A lot of paper is also published. You can see that nanometal for anti-Alzheimer's application, that is titanium oxide, silver, graphene oxide, and gold nanoparticle based metal for Alzheimer's disease. So a lot of paper is published in the due times of courses. And here you can say silver nanoparticle helpful in crossing the blood-brain barrier and various. So this is the application of blood. Sorry. So now I am coming in metal oxide based nanomaterial. Now metal oxide based nanomaterial is very important. Basically, in this area, metal oxide, zinc oxide, titanium oxide. These two types of metal oxide nanoparticle are alumina oxide or iron oxide nanoparticles are very important and very important technological application. And synthesis, how you can know? Sol gel method and various techniques are there to synthesize your metal oxide nanoparticle. And after synthesis of silver metal nanoxide, you can utilize which area you want to. Like metal oxide nanoparticle, number of morphologies, various shape and size. Like because titanium oxide shows the n-type semiconducting property, zinc oxide showing the semiconducting property. That's why titanium or zinc oxide have a greater application in semiconductor industries and also semiconductor industry in solar energy devices application. This metal oxide have a lot of application because of due to unique physical, chemical, and optical properties. You can tune the properties of that particular metal oxide, and the structural, electronic, physical, and chemical properties will be changed. So let us see synthesis of metal oxide nanoparticle, various co-precipitation reaction method, Sol gel reaction method, microemulsion. Microemulsion generally water, oil, and any surfactant. If you are mixing in a proper concentration, then emulsions will be there. Emulsions, mixes, and microemulsions that can be there. So various research are published in order to make the. So you can follow any synthetic route to make the metal oxide based nanoparticle, like chemical vapor deposition method also. Now I am giving example of one nanomaterial oxide, metal oxide, that is zinc oxide nanosurface, and their application in solar energy cell. So after getting some one application, then I will skip the part of metal oxide. So zinc oxide nanosurfaces, after giving the protocol of suppose Sol gel method or precipitation method, you can prepare the zinc oxide nanoparticle. And UV visible, you can characterize, because in UV visible, certain peak will become at particular position about zinc oxide. After the same time and XRD. XRD, in order to prove that zinc oxide nanosurface is in Urzite structure. In Urzite structure, it is the most stable structure of the zinc oxide. In Urzite structure can be confirmed by your X-ray diffraction technique. So now the band gap of the zinc oxide is in the range of 3.30 electron volt. Now, application in this of zinc oxide in biosensor, solar cells, surface acoustic devices, gas sensor, and piezoelectric device. So let us see one application of this zinc oxide nanoparticle in solar energy application. It exists in two shape, that is Urzite and zinco blend. So Urzite is most stable geometry, and it can be explained by this thing. So zinc oxide nanosurfaces, you can say nanocomb, nanowire, nanonails, nanorod, different types of shape and size you can synthesize by various chemical route synthesis and by electron, and different shape and size have different application. So now, so you zinc oxide nanoparticles have a lot of application. How you can synthesize? This procedure is given here. Suppose we have adopted hydrothermal method in our laboratory. In our laboratory, we have synthesized zinc oxide in different shape and size. Nano flower, nano cage, nano ring, different shape and size has been synthesized. We have used hydrothermal method in our laboratory. By this protocol, we have taken the zinc oxide from this side from the market. Just we have mixed some citric acid, and this by this flow chart we can completed the synthetic protocol of zinc oxide. After understanding UV part and after getting the Urzite structure stability, you have applied the zinc oxide as a XRD pattern. So after this part, you can utilize the application part after the basic part of the synthesis. And so this criteria of zinc nanorod actually has been synthesized in various shape and size, can be characterized by same. So characteristics of you can say nano zinc, nano part, bunch of zinc oxide nucleus has been. Solar cell application of zinc nano oxide, emerging solar application, how you can apply and where you can apply. I can explain by diagram of one particle. Actually, in solar cell, you know that solar cell is a renewable energy application, because in solar cell you don't need any extra cost. All the lights are coming from sun without cost, and now this sun have light, that is light have means photon. Now this photon energy will be converted into electrical energy using the cell, that is known as photovoltaic cell. So now photovoltaic cell, solar cell have various generation. That is first generation was solar silica based silicon gel. Now it is solar panel, you can say in every roof, that is a silica based solar cell is there, that is first generation solar cell. But now second solar generation, gallium arsenide solar cell. Now people are working in third generation solar cell. Then third generation solar cell, people are focused on dye-synthesized solar cell as well as perovskite solar cell. So these two solar cells are highly demanding research area of solar cell, and it is the modern latest generation of solar cell. So dye-synthesized solar cell and perovskite solar cell, generally working principle of all the solar cells are almost similar. So now I am going to show that what is the role of zinc oxide in solar cell, how we can modify the role of zinc oxide using the some ionic liquid part of the thing to apply the solar cell application of zinc oxide. You can see some background of dye-synthesized solar cell got the Nobel Prize in 1991. That's why it also shows a gadget solar cell. So why, what was the drawback of only this solar cell is that it have lower efficiency, breakdown of the dye, liquid electrode may leak, light contains volatile organic compound. So we have published this paper recently in 2022. You can see that in my research group have published using the hybrid structure of ionic liquid and zinc oxide nanocluster for potential application in dye-synthesized solar cell. Actually, it published in Journal of Molecular Liquid, which is a high impact factor, 5.8 impact factor journal. So we have given here concept of mixing up zinc oxide nanocluster with ionic liquid. Ionic liquid is also ion pair in molecule. Let us see what happens. Before coming to this application, I would like to show the construction of dye-synthesized solar cell. Solar cell how work? If you understand this part, then you can understand the whole part of solar cell energy application. Actually, in solar cell, dye-synthesized solar cell, actually 4 important parts are there. First part is, you can see here, transparent and conductive substrate, this part. And second part is known as working electrode, that is this part. Green part is known as working electron based on titanium oxide nanoparticle. Titanium oxide nanoparticle will be there, generally played important role to diffusivity behavior. Now third part, this red part is known as photosensitizer, or sometimes we call it dye. And fourth part, this is known as electrolyte. This is oxidation, and electrolyte is that whole transparent oxidation and reduction behavior of your charged particle will be comes there. And fourth part will be here, counter electrode. So generally these 5 important parts in any solar cell can be there. So generally, how can enhance the efficiency of any solar cell? So by various focusing, like in battery, lithium-ion battery or supercapacitor, now people are focusing on various material. Some people are focusing on cathode material, some people are focusing on anode material, some people are focusing on electrolyte material using some nanotechnology. Let us see in this paper, actually we are focused to enhance the efficiency of this solar cell on this photosensitizer solar cell. हमने यहाँ पे जिंक ऑक्साइड और आयनिक लिक्विड का कॉम्बिनेशन लिया है अपने वर्क में, दिस वर्क. Now people also can take the advantage of titanium oxide nanoparticle at this place of the working electrode. So now this work either, and also third part, whatever you can modify, that is electrolyte part, because sometimes electrolyte can be leakage. Due to leakage problem, it can be vaporized. That's why people are also using ionic liquid at the place of here and electrolyte. So now suppose what happens, we have taken the zinc oxide nanocluster plus ionic liquid as a photosensitizer, this red one part. Then what happens if light from the solar energy comes to the on this material? Now these electrons will be excited to the excited state from here. Now electrons come from this ground state to excited state. Now from this excited state, now electron will transit to this titanium oxide. This is a conduction band of your titanium oxide. And the condition should be there. The excited state of this photosynthesizer must be higher than conduction band of your titanium oxide nano level. So now electron will be simply eject from that excited state to conduction band. Through this conduction band of titanium, electron will be diffused through the diffusion and back level geometry. Now this electrons will be back circuit geometry. It will reach to the counter electrode. Now where in counter electrode, your electrolyte will reduce the I minus 3, 3 minus I into I 3 minus. Now this oxidation and reduction cycle will be complete. And from here, now reduced electron will come again to the ground state level of the photosynthesizer cell. Now again, same process will be repeat from here to above part, and this is the complete process. And now again, this process from the taking electron from the solar, now your process will be completing on. So now it is solar cell application and construction of the DSC. Now how we can replace? We have actually focused on photosynthesizer solar cell. So now various research areas you can see, this is the ionic liquid structure. So I am not interested. I have actually synthesized ionic liquid metal nanoclusters. Basically, this is the zinc oxide nanoclusters. You can synthesize also, as theoretically we can show that which types of nanoclusters are very important to enhance the efficiency of your solar cell. So in this purpose, actually we have synthesized or make different types of clusters. Theoretical way also, different types of nano cluster we have make, and we have interacted with your ionic liquid in order to enhance the solar efficiency. How we can check the enhanced solar efficiency of your behavior clusters of your ionic liquid with zinc oxide cluster, various concern binding energy were calculated, and we have also find out the efficiency of work function. Work function of minimum amount of energy required to emit one electron from the system. So we have found that smaller ionic liquid and zinc oxide nanoclusters actually need smaller work function. The smaller work function means we need very small amount of sun energy in order to now. To mean solar energy, we need. Further, we have also shown that electron transfer based on this comparison. We have calculated. Sorry, my voice is clear?
Yes, sir, your voice is clear.
Okay. So I think 10 minutes more, na? 10 to 15 minutes I can take time.
Yes, sir. By 2 o'clock we will find.
Okay, 10 minutes. I think 10 minutes is there.
Yes, yes.
Okay, thank you. So you can see, because in solar cell you know that electrons coming are from solar energy, light. Then it is needed to calculate the band gap as well as work function. If work function is lower, it means that you need less effort to emit the electron from your material, and you can calculate this phi, that is ionization potential, IP minus E lumo and E lumo, and you can calculate the work function, that is ionization potential for electron affinity upon 2. So you can find out this value, and you can calculate the light harvesting efficiency of this clusters, ionic liquid and zinc oxide nanoparticle cluster, which is 1 minus 10 minus F, where F is the oscillator strength of the absorption intensity of your particular nano cluster. So using this simple equation, you can calculate the light harvesting efficiency of various nano clusters with ionic liquid. And we found that with two types of zinc nano cluster, it is showing the largest light harvesting efficiency capacity by 0.39. So due to this concept, we have applied these zinc oxide nanoparticles, various clusters in solar energy application of this thing. And we can also calculate the efficiency of the solar cell by calculating the B0C JSC fill factor upon P in. And how you can calculate this P in is given by various formula. So we have found that this efficiency is clearly increased in the presence of zinc oxide second nanoparticle, which are very, very important application for the solar cell. So now I think carbon-based nanomaterial, very briefly I can show, carbon is one of the most abundant element on the earth. And you know that a part of the bulk level of the graphite and diamond, the nano dimension of carbon-based material like graphene, carbon nanomaterial, and fullerene make a new dimension in the carbon size. And carbon nano-based nanomaterial is important not only in biotechnology, even in energy, high thermal activity, high current density, transparent conductive property, electronic application, transistor, many various applications about it. In catalytic, energy storage application, fuel cell, capacitor, lithium-ion battery, and high electrical physical strength, every area you can see carbon-based nanomaterials are important. What is the carbon nanomaterial? You can see carbon-based nanomaterial are bulk form in graphite form or diamond form. Now, if you are taking graphite is here, you can say only CC bond is there. CC makes the graphite. So this is the many layers of carbon-based material is known as graphite. If you take the single layer of graphite is known as graphene. Single layer if you cut from graphite is known as graphene. So now if you fold this graphene in cylindrical shape, we can known as carbon nanotube. And now if you make this shape in football type shape, we call it fullerene. That is 0 dimensionality. Carbon nanotube is 1 dimensional. This is graphene is 2 dimensional material. So simply you can synthesize in various technique, and here you can see that this is all the CC bond are connected to there. And why novel properties of graphene? You know that we have already shown that because its band gap are coming 0 to 6 electron volt. That's why Raman spectroscopy are very important to characterize it. So how you can synthesis? Various technique, top down, bottom up. Generally industry are using chemical vapor deposition, chemical explosion method, laser ablation, whatever method you can use, laser, electric arc discharge method you can use to synthesize your carbon based material. And after that, you can apply the same and same image in order to also verify how many layers are present in your carbon-based material. 3 to 5 layers, 6 to 5 layers are present. Same and same. And further, most important characterization techniques for carbon-based material is Raman spectroscopy. And suppose you can differentiate the number of layer in your carbon-based nanomaterial using Raman. Raman, you know that Raman giving the information at the certain peak in terms of vibrational spectra. In vibrational spectra, generally, every peak is coming due to some molecular vibration like symmetric stretching, chemical bonding, ring breathing, or something type of vibration. Means every peak is coming due to some molecular vibration, and every material vibrations are coming due to some significant structural way. And हर structure का अपना एक peak होता है रमन में. You can identify, means you can say in simple word, Raman spectroscopy is giving a chemical fingerprint of or chemical identification of any molecules and material. So here you can see that if you have synthesized graphene and graphite, you can differentiate here. Here peak of this peak you are getting in graphene band, one peak G band and D band. G band means in plane bending vibration known as graphene peak. If you have successfully synthesized a graphene, this G peak will become. And if suppose now you have changed the graphene into carbon nanotube, then what happens? You are changing the structure, means you are going to introduce a defect in your sample or disorder in your sample. That's why you are getting a D band in your peak. Suppose this is a monolayer graphene. Now you have filled this graphene with doping with oxide. Now graphene oxide. Then what happened? Oxide is in graphene sample. Now it means D peak, means defect peak or disorder peak. A D peak is obtained at 1300 something about. So D peak obtained at graphene peak in Raman spectra. We can see that now we are successful to synthesize the graphene oxide. Similar way, reduced graphene oxide and many graphene oxide you can pin out, and D band and G band peak are coming here. So G band is very suitable. Graphene are very suitable for supercapacitor and energy. So I am not coming in more application of this part of solar cell of graphene. And very recently, you can see we have published a research paper in applied surface science. Here we have used enhancement of surface enhanced Raman using the graphene and silver nano hybrid. Here we have taken the advantage of silver nanoparticle as well as graphene particle. So we have just mixing the graphene and silver nano hybrid, and we found a very, very important application in case of some sensing application. But we are not material to find. So now we can see the important application of metal nanoparticle in sensing. So actually, you know that I don't know if everyone has heard about the surface enhanced Raman scattering or not, because Raman got the Nobel Prize in India, and Raman the weakness was that only one peak is obtained. Scattering process, only one peak is obtained out of 10 million photon as a scattering technique. So but fortunately, in the presence of metal nanoparticle, the signal of Raman can be significantly enhanced. So means we can single molecule can be detect, or single molecule or atom can be detect using the metal nanoparticle substrate of that, which will mean nanoparticle can enhance the signal of any Raman signal. So that's why we can detect the explosive material or uranium material using the metal nano. First process, we can make metal nanoparticle, silver, gold, copper, or anyone. Metal nanoparticle, just this metal nanoparticle just mix with your small particle of explosive material like TNT, RDX, or any hazardous element. Suppose now I am coming to the part of fundamental property. I cannot say. Suppose this is the detection of explosive in real system. Now suppose now the terrorists are using this RDX and TNT to make a attack on population and attack as a terrorist attack. So now after post event, people of forensic team comes and collect the data. If suppose one powder even on our shirt or in our surface, one small particle are there. If you that particular small particle of that particular molecule, if you put on the metal nano substrate surfaces, then you will find a peak signal in the Raman, and you can identify that this small part of your TNT or RDF, means you can differentiate small particle. Even in liquid form, small one dust is there in nanomolar concentration. You can find out detecting this particle using the nanoparticle. So this is the structure of RDF. You know that this is the nitrogen, oxygen, hydrogen. So small particle dust is there. Just simply put on nanoparticle. Due to surface enhanced Raman technique, you can find out in a nanomolar concentration. This is the technique where you can find out different nano triangle, gold nano triangle, and after some protocol, gold nano triangle, you can put on TNT, trinitrotile, RDS, and three types of different explosive material. And after certain peak, you are getting a small quantity in Raman spectroscopy, and you can identify that, oh, this is RDS or TNT in the presence of. So means overall, we can say that metal nanoparticles played important role as a sensing of explosive material, which will enhance the signal. This is the things of the TNT RDS by detective by this metal nanoparticle. Simpler way, also TNT RDS has been synthesized and collected by this surface enhanced Raman using the metal nanoparticle by identification by this peak. And you can see that 10 to minus 9 mole means nanomolar, means a small drop of the TNT RDS can be very frequently can be identified by the presence of nanoparticle. Here you can see silver nanoparticles and silicon wafer can be. So mainly people are making different types of nanomaterial substrate in order to detect the various types of simpler way nuclear material, because nuclear materials are also very harmful. Nuclear radiation cause the cancer, and nuclear material after nuclear war or nuclear weapon, it is very important to collect. So nanomaterial surface actually important to collect small drop on even in water, in our tap water or in our small part of water, you can detect this uranium using this nanomaterial concentration by identify few peaks in that particular region. By this, even in some surface height like on some stone or some deep water or something like that. So we have also detected some hazardous element using some silver nanoparticle. You can say Ag and nanoparticle at concentration. Actually, this paper is published in Journal of Hazardous Element, more than 10.5 impact factor. Where actually this paper was published in when I was in South Korea. So that very small idea we have taken. A hazardous element citrinine was detected as a sensing at the silver nanoparticle plate using the Raman spectroscopy. So simpler idea was there. So nanomaterial for the biological application, you can also see if you apply the nanomaterial for the cancerous cell, you can suppose this is the pure Raman spectra of pure nanoparticle surface. There is no any peak, and this is the surface silver nanoparticle you can synthesize. Now UV visible absorption of silver nanoparticle is there. Now if you put this silver nanoparticle in your cancer serum, now all the signal will be enhanced. Means if you don't have any signal in Raman, but just mixing the silver nanoparticle in that particular drug or cancer cell, you are getting all the signal from the cancer, and you can identify that this is a cancer cell or healthy cell by comparing this one. So you can see here Raman spectra and just mixing the silver nanoparticle, you can find out every peak in the cancer cell, and every peak have some certain name, like 1030 peak, that is protein peak, and 852 peak, that is protein due to tryptophan amino acid. So every peak has some meaning, and you can identify it using the metal nanoparticle. Also, certain coronavirus, you know that this is the structure of coronavirus. In coronavirus, various types of structure: S protein, hemoprotein, E protein, lipid vial, M protein. So now this coronavirus can be also detected various way, but using the nanoparticle and apply the Raman spectroscopy, combinedly you can detect the virus in very short time of the time. Generally, a paper actually generally published in 2020, they have developed a very small device known as Virion. In this device, they have used the application of silver nanoparticle or gold nanorod, and they have applied the Raman spectroscopy to detect and identify. It is a portable device, very small device, and very cost-effective device. This you can see here. This is the laser light. They have Raman signal, but this is the silver nanorod. They have synthesized in various protocol, and now they have applied this silver nanorod on particular viruses. And in particular viruses, in various protocol, they have detected various influenza virus and various types of virus. They have identified by using the red silver nanorod obtained. So I think this technique was very important, and it can be helpful to identify the various combination of viruses like coronavirus, either influenza virus, dengue virus. Combinedly, you can differentiate to which types of virus are there. So where nanorod synthesis are very important. Overall, I will conclude my presentation. The overall application of nanoparticles is not only in one specific area. You can apply particular nanomaterial, especially any particular nanomaterial, in all types of research area. It is not have any limit, and overall, all the research area concluded by these nanoparticles. So overall, I will acknowledge my collaborators from India, Germany, and South Korea, and also Indian, and my PhD student from Deepak, Hardik, Amit, Mehli and Pradhi for our research journey at IITRAM, and also DST, SERB, Science and Engineering Research Board for funding our research work at IITRAM Ahmedabad. If you want anyone need further more details about my research, they can visit my personal homepage at www.dks.mscr material and research spectroscopy.com. And thank you very much.
Thank you, sir. It's a really very wonderful session. You covered all the parts from synthesis to characterization to applications in the various fields. So participants, if you are having any question, you can ask directly to the sir, or either you can write down in the chat box. Participants,
Hello,
yes.
can you hear? Ma'am?
Yes,
Yes,
yes.
Yes, hello, good afternoon, sir. This is Harshada Mhatre from Pune, sir.
Yes.
Sir, I am working on dye-sensitized solar cell
Yes.
using PO2 nanofiber. So I just want to know where I can found the electrical and optical properties of nanofiber, as we are also seeing that key properties are changing. So I just want to simulate these things by using the SCAP software before experimentation.
Okay.
So where can I these ideal properties like electrical properties and optical properties, because these properties are affect on solar cell performance only.
Yes. Okay, so there are two ways. First way, you can know that cyclic voltammetry experiment is also very helpful to identify the charge transfer or something solar type. There are various accessories available in cyclic voltammetry that directly you can calculate the charge transfer and various optical property measurement. Also, UV visible absorption spectroscopy are sufficient to provide you knowledge about band gap optical property. And there are two types of absorption spectroscopy: UV visible in solid form also and in liquid form also. And moreover, if you want to know particular area, means particular region to communicate, or you can tune the electrical properties or optical property, so simply I can recommend you to calculate the simulation, molecular simulation, like quantum chemical calculation, like DFT calculation. Actually, we have seen in my research work, actually we have shown the different types of cluster of zinc oxide nanocrystal. After understanding zinc oxide cluster, we have also theoretical calculated the band gap, like photo energy harvesting, like light energy harvesting, LHAE value, work function value, optical band gap value, and everything homolumo value. So after getting that concept, you can know that which types of clusters or which types of conditions are favorable to design biosynthetic solar cell. So means after understanding that part, actually we had concluded that the smaller particle or nanoclusters are very important. That's why now we are importantly only focused on that particular part. So even I will recommend you come to overall that is a particle of batteries application. Actually, particle we are going to that is galvanometer. You can see.
Okay.
And you can perform DFT calculations also about your material. You will find a clue. And also there are various measurement, like electrical measurement, dielectric measurement, that is particular measurement properties are also there. Cyclic voltammetry, have you heard about that? It will be more helpful, because cyclic voltammetry have a lot of accessories. In every accessories, you can find out everything.
Okay. Sir, is there any software to check the electrical properties or optical properties without experimentation or without these characterization method?
Yeah, various property, various quantum chemical method are available. Just like our group also using DFT calculation, density functional theory. That is Gaussian and Gaussian software. Also, some software are also there. Quantum espresso. Quantum espresso generally on the basis of physics basis software. It is free software. Quantum espresso is a free software. So it can also show the all this property very better. And Gaussian is actually some cost wise. Granted wise software. Actually, we have also Gaussian and Gaussian, but quantum espresso is free software. You can find out all this property from the your design your molecule and software.
Okay. Thank you, sir.
Welcome.
Any other participant?
Good afternoon, sir.
Good afternoon.
Sir, this is Naresh Babu from Chennai, sir.
Yes.
Sir, recently I've used graphene disposed in oil for machining purpose. So my area is machining, sir.
Graphene?
So, graphene disposed in canola oil. I use base fluid as oil, canola oil for machining. I am using it for machining purpose.
Okay.
So in order to check the stability of nanofluids, there are two methods available from the literature I gathered. One is UV VA spectrometer, the other one is zeta potential.
Zeta potential, yes.
Zeta potential and UV ultraviolet VA spectrometer. So out of these
Yes.
two techniques, so which is the best technique to determine the stability of nanofluids?
Yeah, zeta potential actually giving the information about charge distribution, but
Yeah,
actually overall, if you are working in nanoscience, actually in my opinion, all the properties are very important. Like after synthesis, first step UV visual absorption, because UV visual also showing a lot of application. Not only optical absorption or shape size, even band gap and a lot of types of application you can take from the UV visual. After taking the UV visual, because UV visual is around 10 lakhs equipment and available in most of the institute. And after UV visual, you need to provide the morphology, because without showing the morphology, you cannot proceed. Like shape size, what is the shape and size? Because after changing the shape and size, your properties will be changed. So same and time will be required. And if you are also focusing on some particular application where you are want to utilize the application of crystality behavior, then again you need to XRD technique. And suppose now you are going to work in battery application or any charge discharge method cycle, so you need cyclic voltammetry application. So means every techniques have their own importance. Okay, only one techniques.
Okay.
If you are saying then only UV visual, you can say that we have successfully synthesized nanorod or nano triangle or nanosphere. But after certain time in during the paper submission revision problem, they can ask why you have not taken the electron microscopy. That's why it is a complete picture. UV, same time XRD, and further application according to your choice. It will be complete picture. And zeta potential, sometimes people also know the histogram. What is the average size of your nanoparticle? Because there is no monodispersed particle, suppose. There are few particles are 50 nanometer, 50, few particles can be 10 nanometer. So what is the histogram? What is the population of size distribution? That's why some people want to know BT, some people not to charge distribution like zeta potential. So I think this is the combination of all these techniques are required to complete picture of your application.
Okay.
Okay.
Okay, Mr. Naresh Babu, you want to ask some question?
No, madam.
Yeah, you can drop the message also. I can read here.
Okay, sir.
Okay.
Yes, I have one question.
Yes.
Hello,
Yes.
am I audible?
Yes, sir.
Okay, yes, sir. Yes, actually, myself is Dr. Hardev Singh from Chandigarh University. So, first of all, it was very interesting lectures on the nanoparticles and their functionalization. But I have one question that when we functionalize the nanoparticles with the antibiotics or some anti-cancer drug, is it going to affect the efficacy of that particular drug? Because normally it is mentioned that the drug itself, when it is in the pure state, it shows the high efficacy as compared to when it is conjugated to something else.
Yeah. It is a very good and very mature questions. Actually, same questions was also asked during our revision paper. Actually, both paper actually you can see it was published in nano scale. It is very highly reputed journal. And also we have published one US patent in that research area. Actually, same questions was also asked by reviewer. So we had proved it. Ki our antibiotic activity is not only due to oxidized property. It was we have taken the advantage of some biotechnological people. Actually, one student Puneet Khandelwal from CSIR and CL Pune, he was PhD student at that time. Now he's in America. Actually, he has taken the responsibility and proved some biological approach like ROS activity and something more activity that our antibiotic activity is not lost during the application process, and it is due to the contact or binding of the antibiotic with nanoparticle is only responsible to the showing the blabbing of the bacterial wall in sufficient way. But in most of the scientists actually have doubt about that particular area, whatever your similar thing. But we had proved about that by some experimental evidence, ROS activity or something.
Okay.
But it is a very good question.
Thank you so much.
Hmm.
Thank you.
Yeah.
Any other participant want to ask any question? Either can they ask directly or they can write down in the chat box.
Also, my email address is there. You can note down and you can contact me for any doubt, not only here, even in future.
So you can write down your email in the chat box, so it will reach to all the students. Yeah, you have already written. Yes,
my screen is visualize here.
Yes, sir.
Okay, so you can take from here also.
Yes, sir.
For any doubt, you can call me. Don't worry. After 5 p.m. any day, you can call me. I will be answered.
Okay. In case of no further queries, thank you very much, sir, on the behalf of the organizing committee, our college, and myself personally, that you have given the spare your time with our session in this FDP. Thank you so much, sir.
Thank you very much, Sanju ji.
Thank you, sir. It's been a long time with being within contact with you, and
Thank you.
It's really wonderful to be here with you.
Thank you.
Thank you, sir.
Thank you all. Thank you for listening my lecture for 2 hours. Anyway, thanks very much.
It's a wonderful lecture, sir.
Thank you, madam.
Thank you.
Thank you. Bye bye. Best of luck for rest of the lectures.
Yeah, thank you so much. Okay, so all the participants, the next session will start at 3 p.m. exactly. So we'll be meeting again at the 3 p.m. Till then, you can have your lunch. Thank you so much.